Okay, so we are looking at 1.4 today. And this actually, I believe you've done in Algebra 2. And again, we are stopping after this section to review and test. And then we will not include anything that we've talked about in this part of the chapter in the next test. So we'll take a test on 1.5 to 1.7, but everything that we've done up to this point will not be on that test. So I like to kind of pause in the middle of this chapter because it's a long one with a lot of information. So we're doing some function work. We're doing some operations with functions, adding, subtracting, multiplying, dividing. And so, but the most important thing to notice is like what's going on. So like I have this function right here. My f of x is 3x plus 2. I don't remember if I've said this, but we all know f of x is the same thing as y, right? F just means it's a certain function, and x is like the variable or whatever is in x is what we're plugging into my function. So my f of x is the first one. I've got g of x is this one, x squared minus 1. I've got h of x, which is 2x. And then I've got p of x, which is root x. And so we're going to do all of these operations. So we're going to do f plus g, h minus f, blah, blah, blah. And then in addition to that, we're going to say the domain. Before we get started, can you remind me, what are our like red flags for domain? What is a red flag for domain? What causes me to kind of team time out and be like, wait, I got to think about this? There's two structures. Yeah, Quinn, what's one? A radical, good. Radicals are a red flag. What can I not have in radicals? Ava?
You can't have no negatives.
No
it has
negatives.
to be greater than or equal to 0.
Good. So whatever is under the radical must be greater than or equal to 0. So no negatives. Okay, that's my first red flag. We remember that? Okay, yeah. Ava, you got my second red flag?
Yep.
What is it?
The denominator should not equal 0.
Good. So physically, I'm looking at a fraction. And if I see a fraction, we know that my denominator cannot equal 0. So whatever makes my denominator equal 0 is a problem. So those are the two things that we look for. If it doesn't have a radical and it doesn't have a fraction, it's a normal domain, which is what? What's a normal domain? All reals, negative infinity to positive infinity. So if it doesn't have a radical or fraction, then we're good. It's just normal. So using that knowledge, we're going to go into our adding, subtracting, et cetera, et cetera. So the first one is f plus g. So we're going to add our f function. So I'll say 3x plus 2 plus my g of x, which is x squared minus 1. I'm being extra with these colors. I'm just showing you that we're doing g of x and we're adding that to our f of x. You can combine like terms. There's no need for parentheses because we don't have any signs to worry about. My final answer, I like to write my biggest exponent first. So we'll do x squared first plus 3x. And then we do get to do 2 minus 1, which is plus 1. Okay. That's my answer. That's what my f plus g is. And what's my domain for that? All reals. Good. Negative infinity, positive infinity. Does this ring any bells? Yes, no, sometimes. Okay, that's fine. I'll pretend like it doesn't. All right, next one we're going to do h minus f. So I'm going to do my h function, 2x, and I'm going to go minus f. Now, on this one, I do want parentheses around my f because I need to give that negative to both the 3x and to the 2. So we need to remember that it goes to both of them. That gives me 2x minus 3x minus 2. Combine any like terms, I've got 2x minus 3x is negative x minus 2. And that's my answer for that one. What's my domain here? All reals, negative infinity, positive infinity. Good. We've done trickier domains, so sometimes when we see easier ones, we get all bent out of shape. Don't let it bend you out of shape. Just like it's just that simple if it's that simple. If there's nothing to take out, it's all real numbers. All right, now we're multiplying. So this little time sign in between them means we're multiplying. So I'm going to do f and I'm going to do times g. I'm going to have to FOIL these. So I've got 3x plus 2 and I've got x squared minus 1. So we're gonna FOIL these guys out. 3x times x squared is gonna be 3x squared. I want my numbers to match, so I'm gonna do my 2 and x squared next to give me, oh, did I say 3x squared? It's 3x to the third, thank you. Because the next one's gonna be 2x squared. Then I've got 3x times negative 1, which is minus 3x, and negative 1 times 2, which is minus 2. I guess I could have written this next to it. Okay. What about my domain for this one? Same thing, right? Negative infinity to positive infinity. All right, this next one is finally going to cause a little bit of a curveball for us. So we're going to do h of x, which is 2x, and we're going to multiply that times p, which is radical x. So 2x times root x or square root x or radical x, whatever that is, can I combine those to be anything smaller? No, I'm just going to put them next to each other. It's just going to be 2x radical x. 2x radical x. Kind of ugly, but like that's just what it is. What's my domain now?
0 to infinity.
0 to infinity. Remember on this one, you got to take whatever's under the radical, and that has got to be bigger than or equal to 0. So in this case, I'll draw even my little number line if that's helpful to us. We can be equal to 0, or we can be greater than 0. So we have to do 0 to infinity. Am I going to do brackets or parentheses with that 0?
Bracket.
Bracket. Bracket 0 to infinity parentheses. This x over here, he does not affect my domain at all. You can plug negatives in, you can plug positives in, you can plug fractions in, anything works there. The only problem is the one under the radical. That is not okay, so we have to keep that positive. All right, and then my last one says h over f. So we're gonna do 2x divided by 3x plus 2. 2x divided by 3x plus 2. Okay. Am I allowed to simplify this?
No.
Why not? Say it again.
Like all three have to simplify. All three.
Good. I need this and this to all simplify. I can't just take an x out because there's an x on top and bottom, because there's a plus sign. I can't just take it out of one piece. I also can't do the 2 out because the 2 is again separated by a plus sign. So unless it goes through all three of them with this plus sign, you can't do it. So all three of them do not have the same thing. This is as simple as it gets. Now, in order to find my domain, what do I need to do?
Set it equal to 0.
Good. Set my denominator equal to 0, and then we're going to solve. Minus 2 from both sides, so 3x equals negative 2. And then divide by 3, x equals negative 2/3. I like to set it not equal to 0 so that I know the only thing that does not work in my domain is negative 2/3. Everything else works. The only thing that doesn't work is negative 2/3. Again, if it's helpful, if you like it, I like to draw a little number line to know that everything but 2/3 is good. Everything smaller than 2/3 is good. Everything bigger than 2/3 is good, except 2/3 itself is not good. So how do I write that as my domain?
Negative infinity to negative 2/3
Parentheses or brackets?
parentheses,
Mhm.
and then and then negative 2/3 to infinity. Parentheses.
Very good. Parentheses everywhere. So this one is not just one interval, negative 2 or negative 2/3 to infinity. It's both intervals. We just can't actually include negative 2/3. All right, so not only did we do a little bit of function operations, but we also did a little bit of domain practice. Anybody have any questions yet? We doing okay? Okay. Next one, we are going to do compositions. Does the word function composition mean anything to you? Okay, I would argue that you probably learned this in Algebra 2, but I would also argue you forgot. That's okay. Composition means that we're putting one function into another function, okay? So I've got this notation, P bracket H of 1 end bracket. We're gonna take H and we're gonna put it inside P at its X, okay? So we're gonna start with our H function. So H was 2X. So I'm gonna start with my 2X. And that is gonna go inside of my P function at X. Instead of writing an X in my P function, I have my new expression, which is that 2X. So I'm gonna write radical, and instead of writing X, we write our H function. So P is on the outside, and we put H inside of P. Okay, questions yet? I've got to deal with one more thing. Who knows what I do with this 1? Put it in for X, very good. So I take out the X with my H and I put in this 1. So I'm gonna do 2 times 1, I'm gonna do radical of that. So we know 2 times 1 is just 2. Can we simplify radical 2? Nope, that's just your answer. That's the number that is your answer. If it doesn't give us like a 1 or a 2 or a number to plug into, we'll be left with some kind of expression, so X will be left in our answer. We'll look at that in a moment. Okay. Also, the way I read what we just did is we're doing P of H of 1. So we're doing the P function on the outside, then it's the H function, and then on the most inside is my 1 for X. That is the same way I read the next one. This is H of F of 2. Which function's on the outside in this case? Which is my outside function. No, outside of H or F. H. H is my outside function. Why is it the outside function? Good, because it's of F because it's written first. P was written first, so it was that outside function. H is written first, so it's my outside function. So I gotta go find H. Okay, so 2 of X. So I'm gonna write 2, and instead of writing X, I'm gonna have a big set of parentheses. Inside that parentheses, we're gonna put F. So inside of that parentheses, we're gonna put our 3X plus 2. Now I put parentheses around where that X should be because what am I gonna put in for X in H? 2. Now you can do this in steps. You can do F of 2. You can figure out what number that is and then plug that number into H. I like to do it all at once. Either way though, you'll get the same answer. So I'm gonna start simplifying. What should I do first to simplify? Good, what do I do with the parentheses?
Multiply 3 by 2, which gets 6, and then add 2, which is 8, and then multiply it all by 2.
Good, I was helping freshmen with Algebra 1 the other day, and it's like their order of operations sometimes struggles, and that's why it's so important that we focus on order of operations in Algebra 1, so that when we get here, you guys can just easily breeze right through solving that. Okay, questions, thoughts, comments? All right, the next one is going to be of an expression. So we're doing H of F of X. I have to do which function on the outside? H is on the outside, good. So I know that H is 2X, so I'm gonna write 2 and a big parentheses for whatever goes inside. And then inside that, I'm gonna write F of X, which is 3X plus 2. And do I plug anything in for X this time? Why not? Because it's just X on the inside. It's not an actual number. It's just X. And so now we're not going to get a whole number when we simplify. We're just going to distribute and go from there. So I get 6X plus 4. That is your answer. That is our answer. That's my composition of those functions. I combine them by putting one into the other. Okay, the next one says F and then it says G. Am I multiplying those or am I doing composition here? I'm multiplying those. How do you know that, Michael? There's no brackets, there's no parentheses, there's no like little circle right there, which means of. I'm literally just doing F times G. which actually we've already done. 3x plus 2. If as I'm setting this up, I'm like, oh, wait a second, we already did this. So like you can redo it again, or I can just draw my little arrow. That's the same thing as writing this. So FG is the same thing as writing f of x times g of x, but it is not equal to f of g of x. So those are not the same thing. This was not a composition. So maybe I'll write that. Not a composition. Just a normal multiply. Okay. Cool. How are we doing? Good? Yeah, Zach. Of course. Okay. Next set, I think we got 2 more sets of these. Yep. Okay, yep. We have to end by 1.5, so we're doing great. The next part is what we call implicit functions. I don't think you've seen this before. Is implicit functions, have you ever heard of those? Okay, but do you know what the word implicit means like in English or like a vocab word? Implicit.
But
It's implied. It's an implied thing. So it's like sometimes in class I go, is everybody with me? I know who's with me and who's not, right? That's like an implied, oh, if you're not acting right, let's act right, right? Without me blatantly saying like, hey, put your phone up, right? I'm like, hey, is everybody with me? It's an implied, get yourself together. So these are implied functions. So we're not physically stating it, but it's implied. And there are going to be 2 functions every time we do this. So there are 2 implied functions in all of these. They happen when we have something, when we have a y squared or when we have a y with an absolute value. The reason these are implied is because we will end up having a plus or minus situation, which means that we have to set y equal to the positive version of it, and we have to set y equal to the negative version of it. So anytime you see this or anytime you see implicit functions, all we're doing is solving for y, and we'll just have 2 equations equal to y at the end. Okay, so like let's look at this first one. I've got x squared plus y squared equals 25. Let's get y squared by itself. So first thing we do is I minus my x squared from both sides, and I get y squared equals negative x squared plus 25. Okay, now I'm going to square root both sides because I got to get rid of that y squared. When I square root both sides, I have a positive and a minus. So I'm going to have 2 equations that come from it. I've got the positive version that comes from it and the negative version that comes from it. Okay, a lot of us are super tempted at this point to say, oh, well, I know that x squared is the same thing as x, and I know that 25 is the same thing as 5, so I'm just going to do like 5i x, 5i x or whatever. Are you allowed to do that? Am I allowed to simplify this by square rooting everything? Let me rephrase that. You are not allowed to. Does anyone know why I'm not allowed to do this? Why am I not allowed to simplify this to be like, oh, I've got I, x, and 5? Why am I not allowed to do that?
Oh,
Because what?
it's the 5 slot.
What'd you say, Esther?
I'm saying like the 25.
Oh, there's a plus with the 25. Yes, exactly. That's exactly it, Sterling. The problem is we have a plus sign in between those 2 terms. If they were being multiplied, sure, you could do that, but they have a plus between them. So it's actually easier because we don't get to simplify it. It just has to stay like that. Now, I have got a positive version, so I've got y equals positive radical negative x squared plus 25. And then I also have the negative version, y equals negative radical negative x squared plus 25. I know that's not super cute. I know you probably want to simplify it. That is actually as good as it gets. So we're going to keep it right here. The only difference, and it's a very small difference, is this one is positive and this one is negative. So what I'm just pointing out is that you might want to simplify it. It's actually easier if you just don't touch it. Just don't do anything to it. All right, you ready for the next one? Same idea. What should I do first? Minus x. Y squared equals negative x plus 25. Now what? Square root both sides. Now what?
negative square root. Negative is plus 1.
Good, y equals the positive version, y equals the negative version. Very good. So we got two equations here again, positive and negative. Great job, guys. You're rocking it. How we feeling? Good? Okay. Got two more on the next page. Oh, three more on the next page. We got a square root one, or not a square root one, excuse me, an absolute value one. So I kind of preface that absolute value would work. It's very similar to what we were just doing. Get your y by itself, so I'm minusing x from both sides. I get absolute value of y equals negative x plus 1. Whenever we've done absolute value, we've done set it equal to the positive and set it equal to the negative. So I take away my absolute values and I do y just is equal to whatever it was before. Y is equal to the positive version of negative x plus 1. Now, then I do the negative version, so I do y equals, and I say negative times negative x plus 1. We get to distribute that negative to everything. Y equals x minus 1. Questions so far? All right, we've got two like the ones we just did. I'm gonna be quiet for a minute. I want you to try those. Try the next two. I'll put my answers up on the board in a second. Okay, I've got my answers for D and F up on the board. I'll leave it there for a second. Does anyone have any questions yet? Ready for the last set of problems? Okay. The last set of problems is going back to our idea of composition of functions, but we're going backwards from it. And I'm actually going to change one or two of them just to kind of prove my point most effectively. So I'm actually going to change this one to say, instead of 2x minus 1, you can completely cross that out. I'm going to say that this is 2 times x minus 5 plus 9. And then C doesn't have one, so I'll write one in for C. We'll say, I don't know, 3 radical x squared minus 1. Okay. The directions say find f and g so that f of g of x is this. So on each of these, I'm going to have an f of x function, and I'm going to have a g of x function. Which is my outside function on all of these? The f. F is the outside function on all of these, which makes g the inside function. Sometimes I think the inside function is the easier one to see, so I find the inside function, and then I think about, okay, when I take that away, what is left as my outside function? So looking at the first one, what would my inside function be? What's my g? What's inside? I heard it. X minus 5, very good. x minus 5 is physically on the inside. That is my g of x. Okay. When I take that out, when I had placed it in, it was just an x before this. So now my f of x is going to be the function around it. It's going to be what? 2x plus 9. So when I get rid of that x minus 5, when I didn't have it substituted in, it was just 2x plus 9, and we took x minus 5 and put it in for my x. So my f of x is 2x plus 9. You need an x in both of these equations always. If you find yourself without an x, it's probably because it's when I took out my x minus 5. You're like, oh, well, it's just 2 and 9 is left. No, we had x here because that's what allowed me to plug it in. This became x. Okay, what about the next one? What's my inside function for f plus 2 squared? It's the inside function. X plus 2? And what's my outside function? X squared. All right, next one is f of g of x, and I've got 3 radical x squared minus 1. I could kind of argue a couple different things here. So we've got to do an inside function, we've got to do an outside function. As long as all the pieces are taken care of eventually, I don't really care what goes where. Who thinks they know an inside function? Who can see an inside function? Ryan, you thinking? That's what I would probably say. That's instinctively, that's what I think of first as my inside function. So my g of x is just gonna be x squared minus 1. So if my g of x is x squared minus 1, what will my f of x be? 3 radical x, 3 root x, 3 square root x, all of those things. So if we just take the x squared minus 1, we gotta make sure the radical is taken care of in the f of x. Now, somebody in my last class was like, well, couldn't we just make the outside function be 3x and let my inside function be radical x squared minus 1? Sure, I don't care, but the radical has to be taken care of somewhere. I most naturally think that it looks best if I do it like this, but I could see an argument either way. Okay. We actually have a little bit of time. So you guys are welcome to get started on your homework. I want your 1-3 and 1-4 next class. Okay, so you guys have 14 minutes, got plenty of time to do that.